Good evening, guys. It's Unit 9, Day 2. Tonight we're going to discuss some special lines and how they intersect. Parallel lines are two lines that are spaced equal distance apart along their entire length. They extend forever into space without ever touching. These two lines would be example of parallel lines. You might want to stop and sketch all these down if you like. Perpendicular lines are two lines that intersect at 90 degrees. Intersect means cross, and they intersect at 90 degrees. And that's indicated by a little square in the corner. See the little square right there? We discussed that when we discussed right triangles. The last kind of line I have right here is a transversal line. Let's say I have two parallel lines, line A and line B. I have a third line, line C, that crosses both of those parallel lines. A line that crosses two parallel lines is called a transversal, and that's line C. I've got another set of transversal parallel lines and a transversal line right here. Now remember yesterday we talked about congruency and things being congruent. And we would have congruent angles if they were the same size, same shape. Well, what happens when I take a transversal line and cross the parallel lines? I set up several different angles. In fact, there's 1, 2, 3, 4, 5, 6, 7, 8. 8 different angles that are made when the transversal crosses the parallel. And what happens is, we end up creating sets of congruent angles. The orange angles are all the same size. The green angles are also the same size. The same size. So we would say, if I label these, if I label this 1, can you see that? If I label this as 1, 2, 3, 4, 5, 6, 7, and 8, we can say that some of these angles are the same size or congruent. And we would say something like angle 1 let me rearrange this. Angle 1 is congruent to angle 4. Remember, that just means it's the same size. This symbol in the middle, and I'll show it a little bit bigger here, means congruent. So angle 1 is congruent to angle 4, but it's also congruent to angle 5. And I'm out of room, but I'll put it here. And it's also congruent to angle 8, which means they're all the same size. You're probably thinking we have another set of congruent angles here, and we do. So we have angle 2 is congruent to angle 3, which is congruent to angle 6, which is also congruent to angle 7. And by writing it like this, we're just telling you that angle 2 is the same size as angle 3, and the same size as angle 6, and the same size as angle 7. They are all the same size. Angles 1, 4, 5, and 8 are also the same size. But when we talk about angles, we talk about them being congruent. Now, just to show you, just in case you don't believe me, I've got a little model here, and the camera's going to zoom in and out a lot as I try to pick these up, so sorry for that. So I've got duplicate sets of parallel lines with transversal. What I've done is I've colored the angles here, and I've cut them out. So I can take this angle right here. I'll just pick it up and show you. See how this angle, how they match in size? Now I can take that wherever there's another green angle and I can put it in and it fits because the angles are the same size. Now on 3 and 7 I need to turn them around, but you can see that they are the same size. Okay? You don't have to sketch this one in your notebook for notes. There's no way you can sketch this, but I just want to show you. So now I've got the orange angle right there, okay? And I've taken it, I've cut it out, and let's focus. See how I slide that in? I can't see where it's the best focus for you. And that matches that angle. It matches this other orange angle. If I turn it around, it will match there, and it will match there. And here's why we're discussing this. Yesterday we discussed that the angles that fit together to form 180 degrees are called supplementary angles. So if I have a set of parallel lines with a transversal and I have all these pairs of angles set up, and I know one of those angles, I can figure out the rest of them simply by working with supplementary angles. So here we have the measure of angle 1 plus 55 degrees that we're given, and we'd have to be given one of these angles, guys. We can't do it without one of the angles. Measure of angle 1 plus 55 degrees equals 180 degrees. That's the rule of the supplementary angles. And since we know 1, we can subtract it from 180 degrees. That's 55. And we can get 125 degrees. So the measure of angle 1 would be 125 degrees. Now remember what we learned about these pairs of angles and the congruent angles? The angle opposite, the angle opposite is always going to be the same size. So the size of angle 2 is the same size as angle 3, right? So I'm going to use that principle right now to figure out angle 2. It's going to be the same size as 55. So I'm going to write a 55 right there. I'm going to use the same principle to figure out angle 3. I'm going to look across the intersection and I see 125 degrees. That's angle 3. Now I know my example has a line tilting this way, and this one has a line tilting that way, but it doesn't really make any difference because the point is that the angles opposite of the intersection, those are the angles that are congruent. So to keep going on this, I can see that 55 degrees is congruent to angle 5, which is also going to be congruent to angle 6. So I can write 55 in here and 55 here. Angle 4 and angle 7 are both congruent to angles 1 and 3. So I can write 125 on each one of those. I know it looks a little bit busy, but it's really not. It's just the same two numbers repeating. 125 here, 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 and here. And 55 degrees on the smaller angle here, 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 and here. We're going to do these a lot in class tomorrow. We're going to get a lot of practice with these. So don't worry if you don't understand. We'll work on it tomorrow. Have a good night. Focus. Focus. Come on. So here's another set of parallel lines with a transversal. And if I take another card and set... Where are my cards? Oh, where... I can't find anything.